Hello everyone. In this video, we are going to learn what is a lens, what is concave lens, what is convex lens. Okay, rules of image formation by a lens, and finally we'll see the how image formed by the convex lens and concave lens. So let's start. When we talk about a lens, it is a transparent medium, okay, which refracts the ray of light ray. Okay, so it is a basically two types of convex lens and concave lens. Here, this is example of diagram of convex lens and this is what a concave lens. You see the diagram, okay, so there is a line which passes through the midpoint of the lens, that is optical center. This line is called as principal axis. So no, so convex lens is generally thick at the center and it is thin at the edges. So it is what a thick at the center and thin at the edges. Whereas when we talk about the concave lens, it is thin at the center or middle and but thick at the edges. Yes or no? So that is the main difference. Convex lens is thick at the center, whereas concave lens it is thin at the center. Okay, next point, convex lens it is thin at the edges. It is thin at the edges. At the corner it is thin, whereas at the corners it is at the edges it is thicker. See, convex lens is also called as converging lens. Why? Because if a ray of light is parallel to the principal axis, after refraction, it will converge to a point. Okay, that's why it is called as converging lens. But what happens here? It's take this is the principal axis. If any ray of light is there which is parallel to the principal axis, after refraction, it will diverge. It will appear to meet at a point. Okay, so that ray is diverging. That's why it is also called as diverging lens. So now, next, let's talk about the rules of image formation by a convex lens and concave lens. Okay, first rule, rule number one. Any ray of light is there which is parallel to the principal axis. Okay, in case of convex lens, after refraction, it will always pass through focus. So there are two focus. This is f1. Sorry, this is f1 and this is what 2f1. This is what f2 and this side is what a 2f2. Right now, so if any ray of light is there which is parallel to the principal axis, okay, so this is the light ray which is parallel to the principal axis. After refraction, it will always pass through the focus. In case of concave lens, if a ray of light is parallel to the principal axis, after refraction, it will appear to pass through focus. It will diverge like this. So it will appear to pass through f1. So now, rule number two. If any ray of light is there which is passing through the optical center, okay, so it will go undeviated, it will pass undeviated. In case of convex lens, in case of concave lens also, if any ray of light is there which is passing through the optical center, it will go undeviated. So no, and rule number three. Okay, there, let's take this is f1, this is what 2f1. Any ray of light is there which is passing through the focus, which is passing through the focus. Okay, now so after refraction it become parallel. You can see here this light ray is okay passing through focus. After refraction it becomes parallel. In this case, if the ray of light is directed towards the focus, after refraction it becomes parallel. Is it clear? Next, we'll keep the object at different places and we'll see where is the image formed. Okay, so this is very important. These questions may be asked for 3 marks. Okay, so consider first case, let the object be at infinity. Okay, object is at infinity. Okay, here I have made the table, serial number, position of the object, ray diagram, position of the image and nature of the image. Okay, so first case, when the object is at infinity. When the object is at infinity, light ray will come parallel. So as you know that when the light ray is parallel, after refraction it will always pass through focus. So no, so this point is what f2. Okay, so when ray of light is there which is parallel, okay, to the principal axis, after refraction it will pass through the focus. This light ray will also pass through focus. This light ray will also pass through focus after refraction. So where will be the position of image? At a focus, that is f2 on the other side of the lens. What will be the nature of the image? It is real, inverted and highly diminished, or we can say point size. Point size. Okay, also we can say highly diminished. Highly diminished. Okay, next case. Let's take the object Okay, here this point is f1. Okay, this point is what 2f1. This side what is this f2 is there, and here 2f2 is there. Yes or no? So object is beyond 2f1. Consider the object here one beyond 2f1. So you have to take a two light ray diagram for the image formation. When you take a parallel to the principal axis, what rule says after refraction it will pass through the focus. Yes or no? So when once the ray of light is parallel to the principal axis, after refraction it passes through the focus. Second, you take a passing through the optical center. Okay, so when the ray of light is passing through optical center, this is optical center, it will go undeviated. So where these two light rays are meeting, it is meeting between f2 and 2f2. So here image is formed. Okay, for the object A, B, image is what A dash, B dash. So where is the position of image? Between f2 and 2f2. Between f2 and 2f2. What will be the nature of image? Real image. Why? Because light ray is actually meeting. Yes or no? So we can see the image is real. Real images are always inverted. Real images are always inverted, and it is diminished. Okay. Next case, when the object is at a 2f1. Okay. So you can see this is the principal axis, the line which is passing through the optical center is the principal axis. Okay, this point is what f1, and this point is what 2f1. Okay, now so here object is there at 2f1. So two ray diagram should take a one light ray you take parallel to the principal axis. According to the rule, it will pass through the focus. So this side is what let's say this is the f2. So it will pass through what focus. Yes or no? Second light ray you take a passing through optical center. Okay, so if once it is passing through optical center, it will go undeviated. You can see this is passing through optical center, it will go undeviated. So image is meeting here. Okay, so here only image is formed. This point is nothing but a 2f2. Okay, so in this case, image size is same. For AB object, A dash, B dash image is there. A dash, B dash. So where is the position of image? At a 2f2 only. Okay, and the nature is real, inverted, and same size. Real, inverted, and same size. Next case, when the object is between f1 and 2f1. So we can consider this point is f1 and this point is what 2f1. This point is what same distance. Suppose if it is 2 centimeter, this side also it is 2 centimeter. Okay, this is what 4 centimeter, so this is also 4 centimeter. 2f2. This is f2 and 2f2. So object is between f1 and 2f1. Here is the object. So one light ray you take parallel. Okay, once you know, okay, you already know when the ray of light is parallel to the principal axis, what will happen? It will pass through the focus. It will pass through the focus. You see, this light ray is passing through the focus. Second, you pass through the optical center. You pass through the optical center. It will go and so you can extend this line. The ray of light is passing through optical center. It will go undeflected. You can see for this light ray which was parallel to the principal axis, after refraction, okay, after refraction it will pass through focus. So you extend this line, nothing. Okay, when the ray of light is parallel to the principal axis, okay, this light ray which is parallel to the principal axis, after refraction it will pass through the focus. Now you can clearly see it is meeting beyond 2f2. Here only image is formed. Okay, so in this case, for the object AB, image is what A dash, B dash. Where is the image formed? Beyond 2f2. Image is what beyond 2f2 on the other side of the lens. And in this case, image is real, inverted, and magnified. Real, inverted, and magnified. Okay, let's take a object now at a focus. Okay, this point is f1, This point is 2f1. So where is the object? Object is at focus. Okay, object is at a focus here. So we have to take the two ray diagram, yes or no? One light ray you take passing through the parallel to the principal axis. The rule says it will pass through f2, yes or no? So you can pass through the f2. Second, you pass through optical center. Okay, once you pass through optical center, it will go undefeated. So you can clearly see when the ray of light is parallel, it will pass through focus. Whenever it is passing through optical center, it will go undefeated. Yes or no? So it seems to be parallel, but they will meet somewhere at infinity. So image is also formed at the infinity. There is the position of image at infinity. And in this case, the real image is formed real, inverted, and highly magnified. And a highly magnified image is formed. Next case, when the object is between lens and the focus. Okay, so let's take this is the f1 and this is what a 2f1. Okay, and object is here. So you'll see this side is what a f2. Obviously this is f2 and this is what a 2f2. So here object is between optical center and the focus. Take the two ray diagram. Once you take parallel to the principal axis, the rule says it will pass through focus. Yes or no? When ray of light is parallel, it pass through focus. Second, you pass through optical center only. It will go undeviated. Yes or no? If ray of light is passing through optical center, it will go undeviated. So see, these light rays are diverging. Okay, now so they will appear to meet once you produce it backward. You can see. Okay, so they will appear to meet at any point. So they will appear to meet on the same side of the lens where the object is there, but in this case virtual and erect image is formed. Okay, this image is on the same side of the lens, on the same side of the object, okay, and the image is virtual because light ray is not meeting now. Whenever light ray appear to meet, a virtual image is formed. So this is the for object A B, image is A dash B dash. Okay na? So it is a virtual image. Virtual images are always erect and it is magnified. Okay na? Similarly, okay, image formation by a concave lens. Okay, so we will see the rules first. As already discussed, the concave lens, if a ray of light is parallel to the principal axis, after refraction, it will appear to pass through the focus. Second rule, rule number 2, if a ray of light is passing through optical center, it will go undeviated. And the third rule, if a ray of light is directed towards the focus, after refraction, it becomes parallel. Okay. Now see the image formation by a concave lens table. So there are two cases only. When the object is at infinity, this is the concave lens. Okay, here already I have drawn. AB is the object. So you have to take a two ray diagram, yes or no? So you take light ray parallel to the principal axis. Okay, this light ray is parallel to the principal axis. After refraction, it will diverge. It will appear to meet at f1. So where is the position of image? At focus on the same side of the lens. Okay, na? Whereas what is the nature of image? It is a virtual, erect, and highly magnified. You should remember one thing: in case of concave lens, image is always virtual, erect, and diminished. Okay. Next, keep the object anywhere. Okay, at finite distance. I have taken the object between f1 and 2f1. This side is f1. This side is 2f1. So once you take the AB object, light ray is parallel to the principal axis, it will appear to pass through focus. Yes or no? So you produce it like this. Secondly, passing through the optical center, it goes undeviated. So you produce this light ray backward. Okay, and this light ray is appear to meet here somewhere between f1 and O. Okay, so image is formed between focus and the optical center on the same side of the lens. Okay, so image is what? Virtual, erect, and diminished. I hope you understood these concepts of image formation. Okay, we have one more concept called as lens formula. Okay, lens formula, it is a relationship between the object distance, image distance, and the focal length of a lens. The formula is like this: 1 by v minus 1 by u is equal to 1 by f. This is called as lens formula. where what is u? U is the object distance. What is v? V is the image distance. And what is f? F is the focal length of the lens. We have another formula called as magnification of the lens. Magnification of the lens. Magnification of the lens is nothing but it is the ratio of height of image to the height of object. So magnification is nothing but the height of image to the height of object, or is equal to plus v by u. Okay, generally numericals are asked. Okay, from these concepts, we'll work out the numericals in the next video. Okay, so magnification defines will tell where the object is the same size or enlarged or diminished. If magnification is equal to 1, okay, if magnification is equal to 1, in that case height of image is equal to height of object, means it is of same one size. Okay, if magnification is greater than 1, so image is more than, height of image is more than the height of the object. If the magnification is less than 1, so height of image is less than the height of the object. So these are the things. I hope you understood all these concepts of image formation by lenses. Please practice once. Share this video with your friends and don't forget to subscribe the channel. Thank you.